Every day, we produce large amounts of waste, which are a burden to our environment. Yet few people are aware that waste can also provide a source of energy. Kuettner GmbH and Co. KG offer a process which allows an optimized utilization of bioenergy that can be produced by waste, a significant and innovative contribution to the protection of our environment and climate. The Waste Disposal and Recycling Service Provider, EVG, operates a mechanical biological treatment plant at the International Port of Rostock, where domestic waste from the city and the districts of Bad Doberan, Güstrow, and North Pomerania is processed. On behalf of the Waste Disposal and Recycling Service Provider, EVG, Kuettner, in cooperation with Kompogas AG, designed and constructed a fermentation plant for the processing of organic and wet fractions of residual waste with a capacity of 40,000 tons per year. The plant came online in the first quarter of 2008 and is the first to extract renewable bioenergy from waste in an environmentally friendly process. The fermentation plant is part of a whole number of processing steps which the waste undergoes at the Rostock port. The procedure begins at the reception facility where domestic waste is delivered and processed in a pre-crusher. A drag chain conveyor transports the waste to a drum filter for pre-sorting, where refuse-derived fuels and organic components are separated. The refuse-derived fuels are transferred to the neighboring power plant. Conveyors transport the organic fraction of the waste to the fermenting plant. Here, non-ferrous, ferrous, and medium-density components are separated. Subsequently, the waste is transported to an intermediate storage facility. An automatic crane system guarantees a continuous operation of the fermentation plant 365 days a year. Box feeders and conveyor systems supply the fermenters continuously with the organic fraction of domestic waste. The zone of the plant which processes wet fractions and residual waste treats 4,000 tons of food waste per year. Waste is discharged directly from lorries or transport containers and is then conveyed to the underground bunker. Screw feeders and a grinder move the food waste to the press, where liquid and solid components are separated. The liquid components are fed into a tank and pumped into the fermenter. A screw feeder moves the solid components to a pre-processed container. For a period of 14 days, the material remains in fermenters, each with a capacity of 1,200 cubic meters without oxygen and at a temperature of approximately 55 degrees centigrade. This creates ideal conditions for the fermentation microbes, distributed throughout the mass by large blending, degassing devices. The surplus heat from the plant's cogeneration facilities is used to control the fermenter's temperature. The control of the fermentation plant and interaction with neighboring plant sections is fully automated. After 10 to 12 days, the microorganism's metabolism produces methane and carbon dioxide. In other words, the principal product, biogas, which is transported to the cogeneration plant. Having been desulfurized, the biogas is transformed into power and heat via 2 gas-powered cogeneration plants. This way, EVG can produce sufficient energy to meet its own demand, as well as feeding 3,700 megawatt-hours per year into the public network. If biogas is not to be used for power generation, it can be burned via a backup gas flare. Digestate is transported to an intensive rotting plant via a dry-wet discharge to optimize the subsequent rotting and stabilization process. This way, the Rostock plant guarantees optimized capture and utilization of the waste energy potential, making a significant and positive contribution to the crucial issue of climate protection.